Okay, this is the apparatus we're going to use for part one. It has water in the bottom with a little bit of phenolphthalein, and on top is paint thinner or hydrocarbon mixture. Notice they don't mix. You see that? It doesn't mix. Okay? Okay, this is sodium metal, and you have to keep it under a hydrocarbon mixture to keep it from reacting with the air and the water in the air. And then the next thing I'm going to do is take a piece out and cut it. Okay, there's a piece of sodium. Okay, I'm going to put it on this piece of paper, and then you can see how soft it is because I'm going to cut it with a dull knife. When I cut it, you can see the metallic appearance in there. Can you see the metallic appearance? Yep, and then it gets oxidized. See that metallic appearance? Yep. Now I'm going to cut this in two, and then I'm going to take a piece about half that big and drop it in there to this mixture. And if I didn't have the paint thin in there, we would have an explosion. But this is something I invented, and we take this piece here. I'm going to drop this in to this. Now watch. You ready? You ready to see what happens? Can you see a gas is being produced? That gas is hydrogen gas, and it's making sodium hydroxide. Sodium hydroxide is insoluble in water, insoluble in hydrocarbons, but it's soluble in the water, and it turns phenolphthalein red. Is it turning red? Yeah, it is, isn't it? I'm going to put one more piece in there, just for laughs. And notice what happens, the hydrogen carries it away from the water to save our lives. You see that? Now I'm going to put a rubber stopper on the top. It has a one hole in it. And if that's hydrogen, it should go up, right? We know that from the last experiment. And if I put this over there, it should collect hydrogen gas. So let's let it go for a couple of minutes, or a minute, or maybe 30 seconds. And then how can I tell that's hydrogen gas? Anybody tell me? It's flammable, right? It should burn if it's hydrogen gas, shouldn't it? Well, let's see. I have a wooden split here from Starbucks again. And if that's hydrogen, it should stay in there until I light it from the bottom, right? And if it's more than 90%, it'll just burn at the mouth of the bottle. If it's less than 90%, but more than 10%, it should explode. You ready to see? Let's see. Hey, look, it's burning at the mouth of the bottle, just like it did last time. Look at that. It's burning at the mouth of the bottle. You see? Just like we did last time. You can see it burning now. And by the way, you can see the condensation of the water being produced. There's no doubt about it. That was hydrogen. Still burning. It's all done now. You see, can you see the condensation? Good. But it forms a little layer of oxide that protects it from further reaction, so we don't have to keep it under oil. And what I'm going to do is I'm going to take a little piece out of that. Let me wipe this off a little bit. We're going to drop it into this test tube that has 10 milliliters of water in it. And you can see it's kind of gray. Let me take a, you see it's kind of gray, but that's the oxide coating. The metal itself looks like a metal. But let me watch this. You ready? You see anything happening? Keep watching it. See any bubbles yet? as the reaction proceeds, it'll clear the surface and then it'll start going faster. It's also an exothermic reaction. It makes it warmer and it goes faster and faster, as you'll see. And then what's happening, the same kind of reaction, we're making calcium hydroxide now, and hydrogen again. So that gas, those bubbles are hydrogen gas. And when it goes a little bit faster, then I'll take that same bottle and collect the hydrogen and test it, like we did before. And then the solubility of calcium hydroxide is high enough so that it should turn the phenolphthalein red too. Is it going faster? It is, isn't it? No doubt about it. And when the concentration of hydroxide and calcium ions get high enough, it'll precipitate maybe, and you'll get a white precipitate. Is it going faster? It is, isn't it? Can you see it starting to cloud up a little bit? Yep, it is, isn't it? See, it's precipitating now. Calcium hydroxide is precipitating, and it's going faster. By the way, this test tube rack is really designed for this because it has a black background. You can see the white precipitate. It's going a lot faster now. Should we collect the gas? Might as well, right? Look at that. Some sending rings up there. Shall I go ahead and test it? Let's go ahead and test that. I think there might be enough in there to test it. We'll see. That time we had a little explosion. Did you get it? Okay. Now what I'm going to do is add phenolphthalein to it and see if it has a high enough it should have a high enough hydroxide ion concentration to turn red. Let's see. Yep, it did. So that's pH is high enough to turn the phenolphthalein red.